have learned what is the difference between gravity and gravitation. So gravity is the force applied by the earth on any object on its surface. And gravitation is the force of attraction between any two bodies, of course, which have some mass. So gravitation is the force of attraction between any two bodies of the universe. And this is acceleration due to gravity in terms of density. The basic expression for acceleration due to gravity is G is equal to Gm by r square, where G is universal gravitational constant, capital M is mass of the object, capital M is mass of the planet on which you are calculating this small g, and r is radius of the planet. If I consider mass of the earth and radius of the earth and use this formula, I will be getting the value of small g, which is 9.8 meter per second square. This is the value of g on earth. And the expression which you are seeing here, the acceleration due to gravity in terms of density. When mass is not given, you can use density and radius of the planet and can calculate this acceleration due to gravity on that particular planet. And this is the relation between acceleration due to gravity on the moon with respect to the earth. And you can see from the expression given here, acceleration due to gravity on the moon is 1/6 of acceleration due to gravity on the earth. This means that as it is already said that GE, which is G on earth, is 9.8. So G on moon will be 9.8 divided by 6. Which will be equal to approximately 1.6 meter per second square. And how does this actually, how can you exactly understand this? We will be calculating our weight. Technically, our weight is calculated by using this expression F equal to mg. So if your mass is 45 kg, then your weight on the earth is mass 45 into acceleration. Let us consider it to be 10 for our convenience in this calculation. So you will be weighing around 450 newtons on the earth. When you calculate your weight on the moon, you will be weighing 6 times less than what you are on the earth, which means your weight on the moon is given by 450 divided by 6. And you can calculate how much is that value. If a planet existed whose mass and radius both half of those of the earth, the acceleration due to gravity at its surface, this we are calculating by considering m to be m by 2 and r to be r by 2. These are the values to be remembered. Mass of the earth is of the order 10 power 25 kg and density of the earth is about 5.5 times density of water. This problem we have already solved in our previous session, and these are the equations for a freely falling body. And what is this freely falling body? A falling body or a body which is falling only under the influence of gravitational force. Objects which are falling only under the influence of gravitational force are freely falling bodies. Only gravitational force is acting on them and force. And for such objects, you can write equations of motion as given here. V is equal to U plus GT, H is equal to UT plus half GT square, V square is equal to U square plus 2GH, where U stands for initial velocity, which is 0 for a freely falling object, is final velocity, G is acceleration due to gravity, and T is the time taken in a given situation. H stands for height from which the object is falling down. So these are the points to be remembered for in case of a freely falling objects. When a body is dropped freely from a height, its initial velocity U becomes 0, which means U will be 0. It doesn't become, U should be considered 0, because for a freely falling objects, you don't need to induce any velocity. You drop them and they fall. As simple as that. And when a body is thrown vertically upwards, its final velocity V becomes 0. So when an object is thrown upwards, it's a very general observation. Objects will go to certain height and then start returning back to the ground. And then the maximum height, at that maximum point, their final velocity is 0. Because their velocity becomes 0, they will be surrendering to the Earth's gravitational force and will be returning back to the Earth. And then there will be certain time taken by an object to reach maximum height. Also, it takes certain time to reach to the ground from maximum height. Time taken to reach maximum height, which means time taken to go to the maximum extent upwards, is equal to a time taken to reach the ground again from that maximum height. And both the times are equal because the object is moving only under the influence of gravity. Its time of ascent is equal to time of descent. Time of ascent, which means time to go up. Time of descent means time to come down. So for a freely falling object, time of ascent is equal to descent. And then the distance traveled by a freely falling body is directly proportional to square of the time of the fall. H is directly proportional to square of the time taken to fall. And then certain sign conventions need to be considered while solving numericals. Here is a quick look at those sign conventions. G is taken positive in direction as that of motion. What is the direction of G? Of G is always vertically downwards. It should be taken positive when it is acting in the motion, which means if a body is also falling vertically downwards, as the direction of G is also downwards, now in this case, G should be taken positive. If object is moving up, but G is acting downwards, you can see G is acting opposite to the motion. And in this case, G will be taken negative. Velocity and distance measured upward from the point of projection is taken positive, and the distance measured downward will be taken negative. Upward distance is taken positive and downward distance is taken negative. And velocity which is measured away from the surface of the earth is taken positive, which means when the object is going upwards, its velocity should be considered positive, and when it is moving downwards, its velocity should be considered negative.